part 2 of the chapter 2 PowerPoint highlight. So first part, I didn't do as much skipping because there was important stuff that needed to be explained. I'm actually going to do a little bit more skipping on this next one. So here we're going to move into waters and mixtures and how water helps with those body functions. So a mixture is something where instead of making something new, it's just a bunch of stuff that is hanging out in the same solvent or the same liquid component, and then there's other stuff that is dissolved in it. So that's actually a lot of what our body works as. And a lot of this is based off of water. I'm going to skip through some of this. Okay. So when it comes to our electrolytes being in water, let's go back to our sodium and chloride. Here's our sodium, here's our chloride. So for electrolytes, when they are broken up in water, it's due to the polar covalent bonds in water. So again, our oxygen end is going to be slightly negative. Our hydrogen ends are going to be slightly more positive. So for our sodium, which is positively charged itself, the negatively charged oxygen ends are attracted to it, which means that it's going to point toward that positively charged sodium ion. This way you have essentially a breaking apart of our sodium and our chloride. So that's how they ionize, or how they break apart in water. Opposite case for chloride, which is negatively charged. So our positively charged end where the hydrogens are, they're going to point toward chloride. The negatively charged ends of oxygen are pointing away from that chloride ion. And it forms what's called a hydration sphere. So again, this is just based on charges. Opposite charges are attracted to each other. They like each other. So that's how that polar charged water molecule helps to break up your electrolytes in water. And more stuff about water. Water itself can ionize. Okay, nope, there we'll still keep going. Okay, so with our water, it is our basis, our solvent for all of the different mixtures in our body, and we have 4 different types. So we have solutions, colloids, suspensions, and emulsions. So the first one is a solution. You have really, really tiny particles. It's mostly solvent, and with these really, really tiny particles, they don't scatter light. So here I have a test tube, and I have these little lines going back behind the test tube. So in here, it doesn't scatter light, so I can still see the lines behind the test tube, even though there is stuff in front of those lines. With this type of mixture, the solution will not separate on standing. So no matter how long I leave this tube on my lab bench, it's still going to be this nice pretty blue color. The next mixture is a colloid. So this is a mixture of protein in water. So for example, the plasma in our blood has a lot of protein in it. And so a colloid, again, protein in water, because the particle size is a lot larger, it's usually cloudy. So in this case, I can't see the lines behind it just because of how much, excuse me, how large the particles are. So they are causing a little bit of blockage of light passing through. And this also is permanently mixed just like a solution. So no matter how many times I leave this out, how long, doesn't matter. It's still going to be that same solution. Well, same mixture, not going to separate. So you won't end up with different layers of the components of that mixture. Next mixture is a suspension. So in this case, you have really large particles. So it's going to be cloudy, so kind of hard to see through, or completely opaque because, again, the particles in there are so large. So blood cells being suspended in plasma is an example of this. And with this type of mixture, it's going to separate on standing. So here we have fresh blood, and we let it sit out on our desktop for a little while. And in this case, we have our red blood cells at the bottom. They are heavier. They are the large ones. And so you're going to, well, not only not see any lines behind it, But because they are heavy, they will fall to the bottom of that mixture. So they will separate on standing. And up top, we have our plasma, which is a colloid, so a mixture of protein and water, and it is also cloudy, so you can barely see those lines behind it. If we were really separating this out and you actually could see this, there also should be a very thin layer of white blood cells here between the red and the plasma. The last type of mixture is an emulsion. I don't have a picture of it. I should. But it's of the suspension of one liquid into another. So breast milk is an example of that. So in breast milk, still should need a picture of this. So we have our liquid portion that is liquid portion of the milk, which is proteins and sugars. And that's secreted by one part of your mammary glands. And then there's another part where it is fat or some type of lipid that is packaged up in like a little bubble. And those bubbles are suspended into that liquid protein and sugar mixture. So breast milk has all of the nutrients that a baby needs. And it's actually pretty cool if you can actually Google that. Google breast milk under a microscope and you can see it. And it's pretty cool. Okay. Back this thing up. And this way. There you go, that's better. Okay, I'm going to skip through most of this. It's acids and bases. You guys know that pretty well. But that's also going to come up in some of the things that we do for AP1 and AP2. Actually, we have a whole chapter focusing on the body's ability to maintain its pH. Oh, chemical reactions. Let's go. Okay, so with our molecules, we have bonds in between atoms, and when you create a bond, you're storing energy into that molecule. You break it, you release that energy and able to do some work. So in order to create or break bonds, you have different reactions. Normally, when you see a reaction written, the reactants on the left, the products are on the right. And so there's three different types of reactions. We have decomposition reactions, synthesis reactions, and exchange reactions. So a decomposition reaction is where you take a bigger or larger molecule and break it down into smaller ones. So in this case, broken bonds, energy is released. So just like with digestion, getting energy from that molecule. This is also called a catabolic reaction or an exergonic reaction. Same concept, smaller, releasing energy. The opposite situation is a synthesis reaction where we take little smaller molecules, we are creating bonds, we're storing energy, and we're making them into a larger molecule. So for example, amino acids into a protein. So amino acids are the building blocks to create proteins. So energy is stored. Another type of molecule that's often you'll see is glycogen. That's our blood sugar, glucose, being stored as a larger molecule of glycogen. Another way to describe this type of reaction is anabolic or also endergonic. And then there's some where they just exchange partners and you still end up with roughly the same size molecules. Some reactions are reversible. So in this case, for example, you'll see this in AP2, where we have our reactants and they can go this way towards the right and eventually end up with these molecules. Or you can start off with these molecules and then you go back toward having carbon dioxide. So this actually works with your gas exchange, for example, going back and forth with your transporting your carbon dioxide, and then when you get to the lungs, you go backwards so you can release the carbon dioxide with your breath. So that's just based on the balance of mass between your reactants and your products, so they'll shift back and forward. Okay, reactions. Okay, skip a little bit. That's something that's more you'll need for AP2. Okay, time. Okay, going into organic compounds. So this is how we use what type of molecules you use to make up our body. So they are based on a carbon atom, and then we build from there. So there's 4 types of carbon compounds. We have carbs, lipids, and proteins, which are considered our macronutrients. You'll see that again, talking about digestion for AP2, and also our nucleic acids. Let's see. I'm actually going to stop here and do another video because that's a whole new section. So we'll stop here and we'll have a part 3 for chapter 2.